how many variables you are going to need to describe the system fully. So the f is going to equal to c minus p plus 2. Okay, so that's actually what we know from the phase rules. Here, since we have a binary system, so our c is going to equal to 2. You can simplify this as 4 minus p. So you need 4 minus p degrees of freedom to fully describe the system. Okay, for the binary ideal solutions at Tk, above this p total line is all exists in the liquid form. Here is actually liquid plus gas, and here is just gas form. In the liquid form, we only have one single phase. In the gas form, it's the same. So in these two zones, we know P equals to 1, so your F is going to equal to 3. Okay, that means actually you need to have 3 variables to fully describe the status of your system here. The 3 variables you are going to need will be your chemical composition, X, and also you need to actually know your pressure, P, and the very last one is actually the temperature. So XPT is actually the things you need to fully describe any point in this plot. The same thing happened here for your pure gas form. Things will become different when you actually hit into this area, because right now you have 2 phases coexist inside that specific zone. Your F is going to equal to 4 minus 2 equals to 2. It means you only need 2 variables. You can fully describe your system. And then this 2 is going to contain the temperature already. That means actually once you use one variable, T, you only need one more variable to describe your system inside that zone, right? So it can be either be your mole fraction X or the P total. Okay, and the reason is because once you define a P here, you can use these 2 lines to know your mole fraction as well. You should also see that once you step into this zone, there is actually no points in between this zone. This zone is basically empty. All you have is actually chemical composition at this line or that line. But within that zone, there's actually nothing. So that's the phase rules that I want to talk about. Right now, we actually want to calculate many things. Assuming today you have A and B, and the A versus B is actually 1-to-1 ratio. So your XB is going to equal 2.5. The first question is actually, please draw the binary phase diagram at a given temperature T, and to label your x-axis with XB. This point should actually equal to your PA star. This point should be your PB star. This line should be actually your P total. All right, so let's actually the first question. The second question is actually at what pressure the first gas molecule going to appear? We know the first gas molecule will appear at this point. Right, that means actually you want to calculate the P total at that specific point. And then from the Raoult's law, we know the P total will simply equals to your PA star times mole fraction of A plus your PB star times mole fraction of B. So here I tell you the PA star is going to equals to 100 torr. PB star is equals to 280 torr. Mole fraction B is actually 0.5. Therefore, you can actually just use Raoult's law to get this answer. So it will equals to PA star is 100, mole fraction of A is 0.5, plus 280 times 0.5. You are going to get the P total is going to equals to 190 torr. What it means is actually, if you lower down the P total to 190 torr, you are going to see the first liquid molecule evaporate. The third question is, at P total equals to 160 torr, I want to know the mole fraction of B in the solution phase. I want to know the mole fraction of B in the vapor phase. I want to know the number of moles of B in the liquid phase over the number of moles of B in the vapor phase. What you should know is actually, if you go down to here, so I should actually also draw out the chemical composition of the vapor phase. So if you keep lowering down, okay, at P totals, you're going to hit both curves. So this is going to give you XB. This is going to give you XB into vapor phase. Okay, so how do you actually get your XB? We need to use some of the very simple triangular geometric correlations. You should be able to see that this actually forms a triangle, right? What you want to know is actually the XB, which is actually this line. So if you have a triangle, if you want to know this portion, okay, what you can do is actually, let's say this is actually B, and then the whole thing is actually B prime. This is A, there is A prime. Then mathematically you will know that A over A prime is going to equals to B over B prime. So here basically your XB will be just your B, right? Your B prime is actually equals to 1. So you know my XB over 1 should equals to this over this. So what is this? This is actually your P total minus your PA star. Here is actually your PB star minus your PA star, right? So basically you can write this, okay, XB over 1 should be actually your P total minus PA star over PB star minus your PA star. And you know your P total is actually 160, right? PA star is 100. PB star is 280. PA star is 100. Okay, so once you do that, what you're going to get is 60, 180, so it's actually 1/3. So you know your XB in the solution phase will simply equals to 1/3. So XB is going to equals to your P total minus PA star over PB star minus PA star, and it's going to equals that. Once you know that, the next thing is actually, can you actually calculate your XB in the vector phase? XBV was defined as the P total over PB star times your XB. So the mole fraction of B in the vapor phase will be just, okay, if you calculate the vapor pressure of B over the overall vapor pressure of the system, they will give you the mole fraction of B in the vapor phase. So you just use these very simple definitions where you know your P total now is actually 160, right? Your PP star is actually 280, XB is actually just 1/3. Your mole fraction of B in the vapor phase will simply equals to 7/12. So that's actually how to calculate the mole fraction of B in the vapor phase. For your component B, we know some of them is going to stay in the liquid phase, some of them is stay in the vapor phase. If I have a total certain mole of B, some of them is going to populate in the liquid, some of them populate in the gas, right? I want to know the ratio between the two. So how can I actually do this? To solve this problem, one important concept you should have is that, let's say you have N1 mole of B is in the liquid form and then N2 mole in the vapor form. The N total of B is just N1 plus N2. The things we want to know is actually what is N1 over N2. If I have N1 mole in my liquid phase, I multiply my mole fractions in the liquid form plus N2 mole times the mole fraction in the vapor phase. That should equals to N1 plus N2 times X, where X is actually the original mole fraction of your B. For example, here we say XB is 0.5, so that's actually a mole fraction. Then once you go to a specific P, then you're going to have your XB in the liquid form and then XB in the vapor form. So this X is this X. So once you know this, if I put N2 on the left, then it should be XV minus X. And then on the right will be N1 times X minus X in the liquid form. So I know N1 over N2 is going to equals to the XV minus X over X minus XL. So I can know what is mole ratios between my liquid over vapor form for component B. These things is not easily seen in your plot, so you will need to actually memorize this so that you will be able to actually solve a question like this. That's the things that you want to have, right? So you will know this is going to equals to your x in the v form minus the x, the other one is h minus your xl. Okay? So your mole fraction in the vapor form is, so your xv is 7/12. Your x in the liquid form is equals to 1/3. And then your original x is actually 1/2. This is just your xb in the liquid form, right? This is the xbv in the vapor form. X is just your initial xb assigned in the question. What you do next is just plug the things in, okay? So xbv will be 7/12 minus 1/2. Bottom will be 1/2 minus 1/3. So it will be 1/12. At the bottom will be 1/6. This will be actually equal to 6/12. That's equals to 1/2. So let's actually how you figure out the ratio of conformant B between the liquid over gas phase. So the very last one is actually at what pressure the last liquid molecule vaporizes. From the description, you should know that this will be the point that you have the last liquid molecule vaporized. Here you can see you only have XBV now. You don't have XB, right? Because all of them become vapor. The things you know for sure is actually your XBV is going to equal to 1/2. So the important thing is actually what is your XB then? Because so far you only know how to calculate your P total using your XB, right? I did not tell you how to calculate P total using your XBV. Right? So how do you calculate this? Because eventually you want to use XB to calculate your P total. Okay, and that's actually the things the question is actually asking for, right? Even though you don't have XB, but you know your XBV is connected to your XB through this relationship, right? These are things that we mentioned in the very beginning. So the XBV can be calculated through the ratio between the partial pressures of B in the system over the total system pressure. And here you know your XBV is actually 0.5. You don't know your XB, but you know your PB star. In this case, is actually 280. And then you want to find out your P total. From this simple relationship, you know your P total will equals to 560 XB. The other thing you know is that your P total is going to equals to the mole fraction of B times your PB star plus mole fraction of A times your PA star, right? So you can write your mole fraction of A equals to 1 minus XB times your PA star. Okay, so this is actually equals to your mole fraction of A. Okay, because you know PB star, you know your PA star, then you know you can actually rewrite the things. It will be XB times 280 plus 1 minus XB times 100. And then your P total is actually 560 XB. By putting these things together, you'll realize that you have an equation you can actually solve for your XB. You should be able to get your XB equals to 5/19. So once you know your XB, then you can recalculate your P total use this relationship, okay? 560 times 5/19. That's going to equals to, I don't have the number here, but you can calculate it, okay? So let's actually how you solve the P total for these specific questions.